Hello and welcome to Nanotechnology channel. I'm Marzia Hosseini. In this video I'm going to talk about nano-coatings and their applications. Nano-coatings are defined as nanoscale thin films that are applied to create or improve materials' functionalities. Nano-coatings have many practical applications. For example, they can use in corrosion protection, controlling the fluid flow in porous media, anti-fouling and antibacterial properties, water and ice protection, thermal management, heat and radiation resistance, friction reduction, and self-cleaning surfaces. In this video, I'm going to talk about self-cleaning properties of nano-coatings. Self-cleaning surfaces are materials with inherent ability to remove any debris or bacteria from their surfaces. Creation of self-cleaning surfaces was inspired by natural phenomena that are observed in nature. For example, lotus leaves have self-cleaning properties. In a lotus leaf, the water droplet is slip over the surface, and with solving the bacteria and the pollutant and impurities in the water and slipping the water droplet over the surface, the surface of the leaf cleans. The right picture shows a surface of a lotus leaf that the water droplet create a full droplet on the surface, and with solving the pollutant in the water and slipping over the surface of the leaves have the property of self-cleaning. The history of self-cleaning surfaces go back in 1995 when the first time the self-cleaning surfaces was created by Pez and his co-workers. They coated a glass by titanium dioxide film. The first commercial application of self-cleaning surfaces was developed by Pilkington in 2001. The ability of a surface to self-clean commonly depends on the hydrophobicity or hydrophilicity of the surface, and water plays an important role in the self-cleaning process. In order to determine the ability of a surface to self-clean, we need to measure the contact angle of water on the surface, and this contact angle is affected by the roughness of the surface. Both superhydrophobic and superhydrophilic surfaces have been used as self-cleaning materials. The first picture from the left shows a superhydrophilic surface. In this picture, the water droplet contact angle with the surface is almost zero, and the water droplet spread over the surface. With decreasing the hydrophilicity of a surface, the water droplet contact angle increases. And in a hydrophilic surface, the water droplet contact angle is between 0 and 90 degrees. The third picture shows a hydrophobic surface, and in this surface, the water droplet contact angle with the surface is more than 90 degrees and less than 120 degrees. The next picture shows the ultra-hydrophobic surface. In this surface, the water droplet contact angle with the surface is more than 120 degrees and less than 150 degrees. The last picture shows a superhydrophobic surface. In this surface, the contact angle between the water droplet and surface is more than 150 degrees. As I said, both superhydrophobic and superhydrophilic surface can use in creation of self-cleaning materials. There are many materials and mechanisms to produce hydrophobic and superhydrophobic coatings. For example, with increasing the roughness of a surface with low surface energy material, we can produce a hydrophobic surface and increase hydrophobicity of the coating. The materials that can use for this purpose are includes organic and inorganic materials, silicones, and fluorocarbons. Also, I said that there are mechanisms in order to produce hydrophobic and superhydrophobic coatings. For example, we can use solder method and polymerization reaction, electrochemical deposition, wet chemical reaction and hydrothermal reaction, electrospinning technique, etching and chemical vapor deposition, lithography, self-assembly and layer by layer method. Also, there are materials and mechanisms that produce hydrophilic coatings. For example, titanium dioxide or functionalized titanium dioxide. Also, there are other materials. For example, tungsten trioxide, zirconium dioxide, zinc oxide, cadmium silicate, and polyoxymetalloate. The self-cleaning coatings have many applications. For example, with this property of coatings can use in aerospace industry. The self-cleaning surface coating can use in order to produce non-sticky surfaces. In textile industry, we can produce self-cleaning clothing. In windows, we can create windows clothing. In optical industry, the self-cleaning properties can use in order to produce cameras, sensor, lenses, and telescopes with self-cleaning properties. In paintings, we can use this property in order to produce exterior paints with self-cleaning properties. In solar modules, self-cleaning coatings can use in order to produce solar modules. In marine industry, they can use in anti-corrosion protection, and in automobile industry, we can produce self-cleaning windshield, glasses, car bodies, and mirrors. Thank you for watching this video. If you haven't subscribed to this channel, please do so, and please put your comments and help us to modify the videos.